Hello and welcome to One on One. I'm Vernon Ramazzo, and I'm very pleased and honored today to have as my guest Dr. Roger Pulwarty, who's a climate scientist, and he's here to talk at NEHR's Caribbean Youth Science Forum on the subject of, obviously, climate, understanding climate and change in the Caribbean. Welcome to the program.
Thank you very much.
Second cousin or something, I think, isn't it?
Related somewhere.
Something to that effect.
As I mentioned, either a pumpkin vine or a passion fruit vine.
Exactly,
yes,
one or the other, but definitely some kind of connection there. The climate has really come into its own lately in terms of interest and government concern. Certainly, we now have the new announcement from President Obama that they'll be making some major change to the Clean Power Act. I know you can't talk to that, but it's still being unveiled as we speak. And even big corporations like Microsoft, Google, and Apple have signed up to say they want to be part of this initiative. It's an exciting time for you as a scientist, isn't it?
Very much so. From the standpoint of the things that have happened since we started the first Intergovernmental Panel reports, the idea that we've come to this point is basically how scientific knowledge is built, right? We get the estimates of change over time, and now we're at the point at which many large companies in the world are seeing an opportunity, not simply just to help humanity face the risks of a changing environment, droughts, floods, wildfires. We're experiencing a major drought right now in the Caribbean, as you know, but really to get engaged in new technologies and innovations that actually make money while trying to reduce the risk. And I think this is where the large companies are seeing an opportunity, both to contribute to society in a positive way, in addition to meeting their bottom line.
Now, you're actually an advisor to the U.S. President on this.
I act as an advisor, being part of the National Oceanic and Atmospheric Administration, to the White House Office of Science and Technology Policy and the White House Office of Council of Environmental Quality. They form the major inputs into things that influence the President's Climate Action Plan. And the Climate Action Plan has many pieces, of which you just mentioned one related to energy, another that is related to our international partnerships for how we respond to a changing environment, what information is needed, what types of impacts might we expect, how can we encourage and create the capacity that is needed for different parts of the world, including the Caribbean, for responding to those risks. So there's a full President's Climate Action Plan that is created by the Office of Science and Technology Policy and Council of Environmental Quality, in which we play a role in inputting ideas, science, and quality control.
Now, certainly in the U.S., for a long time, there was a rift, a political rift in many ways, between those who really were concerned about climate change and those who said, no, it's just greatly exaggerated, nothing is really happening, it's not really man-made. Do you think that rift has really largely narrowed at this point?
I think it's a matter of perception in terms of what solutions are being recommended. It's completely, I think, agreed upon that the climate is changing. There's still, on certain sides, a discussion as to what piece of that, what amount of that is anthropogenic. From the standpoint, though...
AKA man-made.
Or human-made, yeah. Right? So from the standpoint of that, however, the fact that it's changing has registered across all boards. So when we say, well, there's differences in how people look at this issue, what we do is meet people where the issues meet them. Right now, there's a major drought in California. Mm-hmm. We work on that issue. There are wildfires in different parts of the United States, different parts of the world. We work on that as an issue in terms of responses. So the question here is, how is a changing climate manifested in terms of the extreme weather and in terms of the impacts that they have? That gives us a chance to pursue the common good without having to fall into what we call the Socratic fallacy. We must agree on every detail before we act. Action takes place a long time after that. If we had to understand all of the mechanics of walking before we walked, we wouldn't walk. Mm-hmm. And what we're seeing are partnerships in terms of the large businesses and companies seeing value in what they do, but also an opportunity to contribute back to society and the world.
To some extent, climate is always changing, isn't it, over time?
Precisely.
So you're saying we're trying to figure out what part mankind is contributing to that change.
Right.
How serious a problem is it right now for us as a planet?
From the standpoint of a changing environment, some of you may have seen the Intergovernmental Panel on Climate Change Fifth Assessment Report, which I was part of, as a convening author for adaptation implementation. Because we, of necessity, have to be very conservative in our estimates, we basically underestimated the rate at which the ice was melting in the Arctic. The rapid changes that we're seeing are, in fact, larger than we thought would happen. So from the standpoint of thinking about climate change, it's very easy to say, well, here's 2100, how do we respond to that? But that assumes we know exactly what 2100 is going to be like. What is more critical is the rate of transitions and changes that we're seeing, and whether or not the way in which our institutions and our communities can adapt are commensurate with that rate of change. So we're seeing changes in the environment, both having a human-made driver and having natural variability. When you combine those, what you have are surprises in the system. And surprises are inherently unpredictable.
Surprises such as?
The drought in California this time has a contribution from background warming of about 10% of its drivers. The drought, however, is larger than anything that we would have expected just from climate change alone. So when you take the natural variability and you add a background change, you get something that can be bigger than you would anticipate. That's a surprise in the system. So our issues are, yes, the predictable pieces of this, but also to be able to work with the states, the communities, and the nations around the world on how we adapt, adjust, and prepare for potential surprises. What makes us robust over time?
To some extent, the terminology has really also changed the conversation, hasn't it? Because people were talking about global warming for a long time. Right. And then people in cold places in the world were saying, it's not getting any warmer here, it's just as cold as it always was. Then we started hearing talk of climate change, which really is a better description of the entire process, isn't it?
Precisely. It captures, the issue was not so much that it was not warming, because the temperature trends globally, in fact, very much increasing over time. We saw a small slowdown in the rate of change because the oceans were absorbing a great deal of this heat, and still are. Warming is important. When we see cold snaps, the question is not why should one happen if it's warming, mm-hmm. It's would it have been colder if you did not have this background warming? And so from the standpoint of global change, climate change, it's not climate change in my backyard. It's a global changing environment. And from that standpoint, climate change represents both heavy, increased rainfall in some areas, increased dryness in others. And it doesn't create those conditions, it exacerbates them. In other words, we already have deserts, we already have areas with large quantities of water like the Pacific Northwest in the United States. For the Caribbean, while we worry a lot about things like hurricanes, and the strength of hurricanes drives our insurance systems, drives our responses, a big impact we're experiencing is continued and prolonged drought in the case of the one that we're having right now. So as you're articulating, the regional differences matter, and climate change exacerbates the extremes in our systems, the floods and the droughts and the high windstorms. That changes regionally depending on where you have those and when they happen.
Now, in terms of public awareness of climate change, I know scientists must have been studying it for a very, very, very long time. But certainly, when it comes to the public and the popular imagination, Al Gore really got the ball rolling, didn't he, in terms of having people talking about the subject of climate change. Would that be a fair assessment? And was it helpful that he actually was talking about it?
So from the standpoint of that long change over time, I mean, Svante Arrhenius, the Swedish scientist, actually had been studying climate change, came up with the idea that increased fossil fuels would actually increase temperatures in the late 1800s. And there were changes in learning over time that actually the evolution of those numbers have not changed significantly. The calculations have not changed even with better techniques. That actually gives us confidence because it means that there's some stability to the way we understand the dynamics of the system. It's not just data, but understanding the dynamics. The creation of an awareness of a changing environment is critical, but we have to be very measured in our responses. So when we have really good assessments like the IPCC, that's what we as scientists rely on. The rest of the communications, the warnings and so on creates an awareness, but it's then our role to help temper some of what is being said by saying that piece of change we understand, this piece of change we don't think will happen, and this piece we don't even understand at all. There's a great deal of uncertainty still inherent, but from the standpoint of the idea of a changing planet, I think raising an awareness, such as the Vice President did, was critical.
But it also gets people into sort of panic mode to some extent, doesn't it? Right. Which isn't especially helpful.
Right. So from the standpoint of, I chose the words raising an awareness very carefully.
So you're very tempered in how you described it.
So yes. one has to think in terms of whether or not, I always like to tell people that I am a climate skeptic. What's a skeptic? A scientific skeptic is someone who lets the data tell him or her what to think. what we
Isn't
know.
every scientist a skeptic?
Every scientist has to be a skeptic. If you're someone who says, oh, it's absolutely changing and I know how it's going to be, then someone who's a naysayer that says it's not changing, those two are very similar because they know the future way better than we do. And so from the standpoint of thinking about alarmism, as professionals, as scientists, and people who are interested in how we respond and react, we have to get the data. Awareness is raised in many different settings, not only in terms of this, but if we take Rachel Carson's famous book, Silent Spring, about the role of pesticides and so on, it helped raise an awareness. From that flows, however, a sense of what pieces of these are amenable to scientific analyses and what simply need policy interventions. So an awareness is raised, and that helps. But so are the people who are critiquing the scientific information and who are critiquing climate change, because that helps us advance our own science. Let's answer those questions on both sides of the board, and between them come up with an answer. So I find the critics as useful as the people who are.
But I guess also when awareness is raised,
it.
funding is also raised, isn't it? And that's essential for good science, to have the money to be able to undertake good science.
I don't know that there's a one-to-one map between the raising of awareness. There's a lot of awareness being raised, but public and leadership have to be engaged at the same time. That's not always the case. And so I'm not sure that I would agree that raising awareness simply translates into resources. What is interesting is if we can speak to the impacts that people are experiencing in terms of extreme events, droughts, floods, hurricanes, and so on, then how we deal with those certainly requires much more engagement by the private sector, by the governments, and so on. And that will involve resources not simply for studying these events, but resources for how we respond.
Now, it occurs to me that climate science must be a really difficult field of study to engage in, because you're dealing with very complex systems and the interaction of those complex systems. It's almost mind-blowing when you think about it, because you're dealing with everything from water temperature to ice caps
Right.
to any number of things happening at the same time, and how
So
one affects the other.
It's a highly complex. The climate is a wondrously, beautifully complex system. When we speak about the climate, we're talking about the fluid dynamics of the atmosphere. We're talking about the fluid dynamics of the oceans. We're talking actually about the chemistry of the oceans, the chemistry of the atmosphere, the role of land surface, the role of sea ice. I always like to tell people when they say, well, how can you tell me what it might be like in the next 50 years when you can't tell me what the weather will be like in the next 2 weeks? And I said, I'm going to make a forecast for temperate latitudes. Next winter will be colder than next summer. That's a year from now. I just made a completely perfect prediction that is going to be accurate. That's because the things I just mentioned controls what we call the boundaries of climate. The sea ice, the land surface, the oceans, they are the slowly varying pieces of the climate system that actually condition how many extremes you get. The weather piece of it is what we call an initial value. You perturb the famous perturbation of the atmosphere by butterfly wings, creating chaos, then weather. That's actually what we call an initial value problem, an initial disturbance creating weather phenomena. What controls how many of those you see? These boundaries, the sea ice, the margins, things like that are longer lasting, like El Nino and the Atlantic multi-decadal oscillation that actually modulates the amount of hurricanes we get from decade to decade. Those are the things that are linked from the standpoint of climate. And for us to understand both the complexities of the fluid dynamics of the atmosphere together with these boundary conditions is an extremely complex problem. And that's what makes precipitation, the movement of water in the atmosphere, a very difficult thing to model. However, the projections of temperature are much more straightforward because of the projections that we have from how these surfaces vary, what the sun is doing, and everything else. So we're pretty confident of the projections of temperature.
No, it became very sort of popular over the last maybe decade or so when we had extreme weather of any sort to say it's because of climate change. That's not necessarily the case, is it?
Correct.
Climate change is taking place over a very long period, but you will have bad storms no matter what the climate is.
So climate has, as you mentioned, climate has always been what we call non-stationary, right? It's moved up and down for periods of 2 to 3 years, for periods of 10 years, for periods of millennia. What is different about this one is that the background climate, the background temperature is increasing at a rate at which we have not seen and have not experienced within the human evolution.
How much is it actually increasing by?
And so what we're seeing right now is that since the Industrial Revolution, the temperature has increased by about 0.85 of a degree C. Now you might go, well, how much is that? The average temperature between the Ice Age and the present time on the Earth is only 5 degrees C. That's the average difference between the Ice Age and the present condition. So 1 degree matters a great deal. Why does only 1 degree matter? You put more heat into the air, you pull more moisture into the air. You pull more moisture into the air, you create heavier rainstorms in some places. When it rains all of that, somewhere else is not getting the rain, so a drought is exacerbated. So basically the driver, the major discovery of meteorology since the 1960s has been the role of heat and moisture in the atmosphere. And that basically tells us that even small changes in the temperature of the atmosphere actually can have dramatic changes in whether or not you get heavy precipitation event or dry periods.
And those dry periods can affect populations in large parts of the world and disruption.
The flooding from getting more rain can certainly disrupt not just work, but have, as we know, are linked to disasters depending on where we build. Dry periods are extremely critical. One of my jobs is to lead the National Integrated Drought Information System for NOAA. And from that standpoint, the extended dry periods have an impact on our agriculture, on our livelihoods, and our water supply, not simply for things like agriculture, but even in the case of the Caribbean. If we have delayed dry seasons, we're trying to find additional water to supply our tourist industry. And that's a major issue on islands. It also relates to wastewater and sanitation during dry periods. So droughts and floods have significant impacts, and the potential exacerbation of those by the background climate change is a cause for concern.
Is there any point at which the global temperature, would be catastrophic and inimical to human life?
From the standpoint of the past periods in the Earth history in which there have been extinctions, they have had to be fairly dramatic. A general statement like would it be damaging or catastrophic for human life is regionally based. Right? It depends on where people live, where developments have taken place.
Can they feed themselves at that
Can they feed themselves, or are there markets that are providing their needs? I don't think you're going to see that. But what you are going to see into the future are difficulties with addressing the present risks that we're facing as they get exacerbated through climate change. We have experiences with such things. When there's an El Nino event happening right now, a warm event in the Pacific, what's the link to our region? Well, we see drought. That's what we see. And it's a large event that's happening throughout the Caribbean right now. That gives you a sense of the potential impacts that we would experience under a changing environment. The projections for the Caribbean have basically been you might see stronger hurricanes, but not more frequent ones. And we might see extended periods of drought driven by a warmer Pacific Ocean. So people come to me and ask, well, are you telling me we'll see stronger hurricanes? Doesn't that mean more rainfall? And you're telling us we'll have drought?
It doesn't necessarily mean that at all.
Every desert is shaped by heavy rainfall. But you go to the desert and it looks completely dry. Having severe events, heavy rainfall events, and longer dry periods in between them is what's being projected for the Caribbean region and some other parts of the world, such as the Mediterranean.
So really and truly, small island states are among the most vulnerable when it comes to climate change.
As we've heard from over the years, there's certainly this issue concerning a rising sea level, the impacts not only on erosion on our coastal infrastructure, but on our water supply, the near-shore water aquifers. So sea levels are critical, yes, but so is water supply itself. We have a long history, as you know and others know, based on what we grow in the region, the rise of the tourism industry along the coast, completely based on our history, the movement of people with the loss of preferential agreements for agriculture towards the coast for jobs, and the increasing weakening of our food and water security in the region. Those things are existing and changing over time. Adding the climate change signal onto that simply exacerbates those concerns. So from the standpoint of small economies, we're in fact extremely vulnerable.
Given the complexity of climate science, I want to focus on just one area which probably couldn't be further away from us if it tried, the polar ice caps.
Right.
There's a lot of talk about that. You mentioned it earlier on. They are melting fairly rapidly. People will think, well, it's no big deal. But that really has a major impact on the health of the planet, doesn't it?
From the stand, as I have mentioned, one of the drivers of the climate system is sea ice. The concentrations of ice at the poles, Arctic in particular for our region, because it's helped modulate many of the weather systems and many of the modes of climate, such as the North Atlantic oscillation that we see that impacts our region.
Isn't there also an albedo effect as well?
It's a connected system. Yeah. Right? So what we begin to see is this. As sea ice declines, the water below it is of course dark. That water begins to absorb heat. It makes it very, very difficult to create more sea ice to help us build back those systems over time. One of the things that we'd underestimated before was that we estimated that the warming would begin to melt, which we're seeing in the data, would begin to melt the ice. What we didn't calculate was that that water that was melting at the top was also percolating down to the bottom, and the ice was melting from both sides. That changes the rate at which things happen. So you do have, as you just mentioned, the albedo effect also when you expose the water below, which actually absorbs more heat. The sea ice, of course, is related to potential increases in sea level. So we're intrinsically in a completely tied in and connected world. We can't simply say that we're islands in the Caribbean and therefore our problems and our issues are local. We need to ask what needs to be solved at each scale, including governance of our international systems.
Is it fair to say that CO2 is the main concern when it comes to climate change?
From the standpoint of, and I think you quite rightly mentioned this issue, not just of global warming, but of a changing climate. The variability of our climate system, things like El Nino, Southern Oscillation, how these produce droughts and floods, longer decadal signals, these are all critical. We know that methane is a strong greenhouse gas, water vapor is one of the strongest greenhouse gases, but CO2 is the one that's being added at the quickest rate into our systems. And you might ask, well, how much does a simple sort of 0.4% of the atmospheric content, why should that matter? Well, the more you put into it, the more is radiated, heated, and reflected within the atmosphere, keeps the atmosphere warm. CO2 is the most critical greenhouse gas. It's also the one over which we have the most influence. It's extremely important, but as I mentioned before, the combination of variability and change is really the climate question.
Mm-hmm. But we've had, I mean, the one that, when you say we have the most influence, it's a very large world that we live in, and obviously governments have some impact on how these problems are dealt with. So even if, let's say, the US is now very wonderfully implementing some changes that have to be implemented at some point, you'll have other parts of the world that are saying, hey, you had your time to have your heavy industries and everything and get wealthy. Now it's our time. So don't tell us to cut back on pollution. And of course, the Kyoto Accord went nowhere. So.
Went nowhere. Yeah. So from that standpoint, we can say that it went nowhere, but here's what it exposed. For a long time in economics and environment studies, we treated those as two things that were orthogonal, that if you traded off on one, you lost on the other. But yet we're seeing rising markets in renewable energies. We're seeing rising markets in efficient technology. We're seeing the United States is actually using less water in total, not just per capita, in total, than it did prior to 1995. So there are efficient technologies that are being marketed to be put into place. So what we see, and what you can see from the President's plan and everything else, is an opportunity to lead and be innovative. But the trail is not simply saying, wow, let's create some upfront risks and show that we can handle those risks. No, these are deliberate investments in selling products and services that can help us deal with climate change and help improve the markets.
So it's boosting the economy at the same time as it's helping the planet.
In the assessment over time, the upfront investments can seem large, as with anything else, but the upfront investments lead into the innovations that actually boost both the economy and the environment. And this is actually the nature of renewables. This is the nature of efficiencies. The thing to be overcome is this. We always have this assumption that if we're asked to be more efficient, that hurts our well-being somehow. That's the risk. That's our perception over time. Not just economics, but wow, it entails sacrifices. Anyone who looks at refrigerators from 1960 would know they were bigger then, they used more energy, they were louder. The ones we have now are more efficient, smaller, use less energy. They're actually better. So there's not a one-to-one trade-off with the use of more versus our well-being. And I think that's part of the perception that we have in terms of our communication and in terms of our economies we have to overcome.
Well, Dr. Pulwarty, we're out of time for this interview, but you've happily agreed to do a second one, so we'll continue our conversation tomorrow. It's been a pleasure having you in the program.
Thanks very much for having me.
Thank you so much for being here. You've been watching One on One. Join us again tomorrow for part 2.